Okay, good afternoon, everyone. And it's good to be here. And to begin, I think I appreciate the leadership of DSN. Can you give a round of applause for the leadership, the team that has brought us here? Yeah, we'll say thank you to everyone. And so while my slide is getting ready, it's good to be here. So I remembered DSN made us, especially me. So I had the opportunity to be part of the first bootcamp, and from there we got the fire burning, and here we are, by the grace of God. And it has been a well-driven journey. So I can tell you for sure that you are in the right path to impact world generation, innovate solutions, and make things work for your world and your environment, and giving hope for this nation, Nigeria. Okay, so are we ready? 1 minute. Okay. To give us an introduction to what I will be speaking on is leveraging Azure for scalable model development. And one thing I want to, let's ask a question. If you started modeling like over 5 years ago, can you raise up your hand? Like if you had experience doing modeling, okay? So I remembered the first boot camp, we had a competition, and we had to build a model using Azure ML. Then there was a lot of issues. One, issues with data transformation, feature engineering, selecting different model. We have a lot of things to battle with. So beginning our career as a data scientist, data person was a bit tough, because we need to understand the nitty-gritty of the model before you go into development at all. So I think that was a bit advantage for us. But as we proceed and as we progress in career and as we face real-world challenge, we discover that what we started with is not enough. And that is what is now ushering us into this world of understanding and how we can leverage Azure for model deployment in a very scalable environment. Keeping in mind that probably, I know maybe some of us who participated in the hackathon, and probably you have a maximum of, let's say, 100,000 rows. You train your model with it. You try to do some fine-tuning to get your model work. But when you get to the industry, guess what? Guess what? The data you'll be working with, maybe minimum of like, say, 1 billion. Yeah, so if you want to, something that will work, maybe 1 billion. I was having a chat with my colleague and said, Edward, the data we are moving, just 6 months, is around 4 billion. And he said, Edward, it's taking time. I said, that's the beauty of data. Yeah, though sometimes they will say, it's not about big, it's about quality, right? Yeah, that's fine. But sometimes when you have, especially in some industry, the bigger the data, the better it is. And that is why we are here, so that we understand what we need to do and the beauty of the technology called Azure among various cloud services that could be used for model development and training. Okay, I think I'm up, right? Almost. Okay. Okay, so, and that's why we're here, and I'm just going to explain briefly to us, and I would like to just, please, I think I have a page. Can you go to that page? The next page, please. Okay, yeah, so, okay, the next, before this. Okay, so please calm down. Please relax yourself. Don't make it too technical. And don't see me. I want to ensure that I don't use too much buzzwords so that I won't get distracted and will get scared like, oh, Azure. I know we'll be hearing a lot of things. Today is a Friday. Let's calm down and let's Let's see, and let's journey together in the flow. Okay, yeah. So I would like to tell us the journey begins from a description I have, our native means of farming in Nigeria, maybe years back, and now we are trying to transition into a better means when you talk about scalability. So you discover that the guy at my left can scale better than this guy, right? So because this woman, probably she can make maybe 10 ridges per minute max, but this guy, in minutes, the tractor can make more. So we are talking about scalability technology. Okay, so and I have few content for us this afternoon. So we'll be speaking through some key features of Azure ML and also some technologies, and it's going to be brief. I'm going to, I think we've seen this before. Okay, like I mentioned that Azure ML is a cloud service, and it has some key features. When you talk about scalability means that you're able to grow big when needed. And we talk about automation. So how do you feel you have a model running and you don't need to monitor it? I enjoyed automation a lot in my career, and sometimes people think I'm working hard, but I've created a system to automate it, and I'm fine. And people will be feeling, oh, Edward is working. Oh, wow. It's the work of automation. Integrating with other services and easy deployment. I remember my first interview. Okay, some of session I've had, we were given a test question and we were asked to deploy it before we submit. So with Azure, you can seamlessly get the endpoint to deploy your solution. Okay, and so we'll be talking into some key features of Azure, and the first thing we'll be talking about is AutoML. Let's go back to time, and that's why I asked the first question. When we started data science as a career, if you're working on a classification model, you need to try nothing less than 5 approaches, or probably 5 algorithms. You do probably decision tree, you do logistics, and you keep trying a lot. And you need to find which one has the best accuracy, F1 score. You keep trying a lot of things. And well, when you get to a time, you just feel like, okay, I've exhausted my option, I'm fine. But with Azure AutoML, you just passing the data into the system. There are other AutoML applications, but I think I would like to make mention that Azure AutoML has a more robust architecture and processes with a lot of libraries it is calling from. So with the AutoML, you just need to sit down and look. It does the transformation, it does the feature engineering, it does the data cleaning, and at the end of the day, it comes up with the best model accuracy metrics and tell you, okay, I'm recommending you to do this. One of the advantages of this is that in the industry, you don't have much time. You don't have the time. So most of the time, we spend our time on a more strategic thinking. So, but with the AutoML, it's helping us to take away some heavy lifting of our table. And one of the key features of AutoML, like I mentioned, you have automated model selection. It can select out of multiple models for you. Data preprocessing. Preprocessing, for instance, you want to handle outlier. You want to handle missing data. Try to check different algorithms to fit or to fix your missing data. The AutoML is going to take care of that for you. Hyperparameter tuning. Can somebody tell me? I don't want it to be a one-way discussion, as much as I don't have much time. So what do you understand by hyperparameter tuning? So it is when you are trying to just adjust, just as if you are adjusting the focus of a camera to an optimal value that will capture, or probably that will explain the model. So when we started the career, I think when I was preparing this, I remembered how we started, and we don't have all this technology to assist us. Where we need to do them one by one, when you need to try different parameter, and you keep reiterating. I remembered we did one of the boot camp. I can see many people submitting nothing less than 500 submission, because they keep trying different parameter tuning to ensure that they get the best out of it. And you can also, with auto ML, you have multiple tasks like classification, regression, time series, and also assemble interpretability and model deployment ready. Another advantage of this is that the dynamic scaling. So I think I've mentioned a few things. The dynamic scaling, reduction in cost. If you are asked to set up a database or probably set up your own server to build some model, I know most of us might not be able to afford it, but you can use service pay as you go. Probably you just subscribe for 2 hours compute resource and you use it and you're fine. And so in terms of cost, it has a more reduced cost and no coding accessibility. So in case you don't know how to code, the question is this making us lazy? That's a poor question. Is it making us lazy? Is it making us lazy? So if you believe it's making us lazy, okay? So the rest of you believe it's not making us lazy. Okay, fine. So do you understand that though it's not making us lazy, because it gives you room to think more. Yeah, you need to have some level of thinking. Like the same way they talk about generative AI, you need to have some level of intelligence before you can interact with this system. So it's not making us lazy, because it's only going to give you room to think more and give you ability to build more with little. Okay, so we have different use cases, and which we know, I know we are very familiar with, Chon and among many others. Okay. So another one I would like us to talk about in Azure is distributed. I call it distributed and parallel training. So when we were making up this, I had a discussion with Faith, and I was saying, you want to cook a bag of rice on a 1 kg cylinder. How long is it going to take? How long? It's going to take time. A bag of rice, because you need to put it in batches and you start cooking. But what if you try to do something like, you get like 4 or 5 gas, 1 kg or 5 kg each, and instead of cooking 1 kg at a time, you are cooking 1 kg in 5 places. That will be a bit faster. And what if you now have like 100 gas stove and you're able to distribute in 500 grams? So that means the readiness of your model is a function of your compute, which has a relationship with how you can train your model in parallel. And I remember some years back, like the word of using parallel technology came up. If you've heard of Hadoop, all these HDFS and the likes. So I now discovered that having a distributed platform makes things work, because we've gotten to a world of big data. So we need something to help us share the work and make it work. Okay? And we have some use case. So one of the things it does is that it helps you do what we call data parallelism, whereby your data is distributed, like what I explained. And we have hybrid. We have the model, and we have the hybrid, whereby you combine the data and the model, whereby they are all distributed across different nodes, and they are all working. And that's one of the beautiful things. You might not appreciate this if you've not been in a world whereby you are training a model for 12 hours, and you keep looking at the model, and the thing keeps rolling, and you are scared, will my hard drive crash, will my system hang, and you keep training. But when you get to a world where everything is in parallel, you will enjoy this, and you see that in little or no time, you'll be able to get some value out of your model. Okay, and how this works, it has something called this, like the background of all of this technology sits on what we call the compute cluster. So compute cluster means different system. These different systems, our laptop coming together to form a cluster, and such that when we are running a parallel analysis, they are all functioning. They are taking up a quota of the load to get the work done. So, and with that, using Azure, you can dynamically scale. So the server can discover that, okay, 2 servers, 3 nodes is not sufficient for this job, automatically scale to 4 nodes. When it discovers 4 nodes is not enough, it automatically scale to probably up to n node that feels it is at optimal value. And we have different framework for our distributed training. Not all applications, not all libraries work with distributed framework, but we have some couple of our day-to-day framework like TensorFlow, PyTorch, and Orovode, right? And I'll be talking to Pipeline very soon, and it's part of what we'll be talking to. And we have another thing. So, can you hear me? Yeah, you can. Okay. So, we also have example of workflow, how you can have it distributed. You can create and configure your compute cluster, write code for distributed training, and so once you're done, you submit the job, and also you can monitor the process of your training in a distributed environment. Okay, and some of the advantages of distributed training is, like I mentioned, it trains faster. You can scale. I can tell you, what we are talking about, they are practical, and I think I've seen them in the industry, and we can't overemphasize them. Talking about scalability, because you need more node, we need more servers to make sure your model comes out first, and cost efficiency, and the seamless integration. And we have a few use cases. And has anybody done a project on image and video processing here? Anybody? Okay, fine. Okay. So when you are analyzing videos, you understand that it requires a lot of compute power. So at the point of view analyzing, or probably try to get an inference out of your analysis, or probably your video feed, you need a compute that is in a parallel work structure. And that is one of the leading use of using distributed training. And we have for NLP, you can imagine how the Llama 3, the ChatGPT model was trained. So they can't happen unless they work on a well-distributed environment. And with distributed training, you can be sure of what we call hyperparameter optimization. So with this, you won't be using your resource in an inefficient way. So I think I have just two more major points, and another one is what we call the hyperdrive. Do we know grid search, right? When we do grid search, one thing about when you are training a model and why Azure looks a bit better is you have a lot of parameters you are expected to pick from. Like I mentioned, when we started our career, most of the time we are uncertain what parameter to be used, or what is the best parameter to be used in a model training. So we try a lot of things, but with the hyperdrive, you are sure that it's going to help you get the most optimal parameter needed for the model. considering the data. So it's just not going to pick any parameter for you, but it's going to pick something that will work for the model. And those are one of the things that makes Azure stand out. And we have it can automate hyperparameter tuning, like I told you, to find the best model, optimize parameters, like the learning rate and the number of layers. So if you've done something on TensorFlow, you understand that your model, the accuracy of your model sometimes is a function of how many hidden layers you have, and you keep trying different hidden layers to be sure that, okay, you are not underfitting or overfitting the model. So, but with the hyperdrive, it's going to help you with getting the best hidden layer, the best parameter that needed to be used for the model. And also, especially for this, it's going to help you search for a range of configuration in parallel. So you are having less mental work to do. You are going straight into your model development. You know what is needed to be done, and you know the property your model will be carrying. Okay, and one of the components which I mentioned, the hyperparameter, it's going to help you search through the space, like you can search through, say, discrete value, continuous values, and it can give you some strategy for search, like doing some random search, looking for the best parameter to use, and it can also help you in identifying what we call the early stopping. So these are some of the things the hyperdrive helps you, especially when you are building your model. And the flow works like this. It starts with define the search space. For some of us that have done it before, you need to tell the model, okay, I want you to search the parameter to use, probably within the space of, say, 0.01 to 0.1. And so the model, so the grid search has a space to search from, and you configure the search strategy. Is it some level of incremental search, or probably some random search? We have what we call the grid search. The grid search means that it's going to search through all possible options of the model, and you can also set up your, we call it early termination process, which tells the system to say, okay, when you get to the most optimal parameter, you have the right to stop. And with this, you can submit the experiment, and with moving forward, you can now monitor and retrieve the best model. So with that, having selected a lot of parameters to train your model, you'll be able to select one of the best model. And like I think there's something that keeps occurring among everything, is this four. Especially the three: the scalability, the automation, cost efficiency. But now you have a framework that is very flexible. Okay, and we have some use cases of the hyperparameter, which we have from one of the use cases, the NLP, that is optimizing parameters for text classification model. And to enjoy this better, I would most of the time I always say, advise my guys. I say, see, pick a project and do. So picking a project means maybe we can form a group and say, okay, we want to do a research into use of NLP, and we are leveraging Azure as a technology. With this, we are going to see the beauty of what we are talking about. Okay. Finally, we have what we call the pipeline. Okay. One thing about pipeline is this. Pipeline is that guy that can get the work done for you without moving a needle. After maybe in the process of model development, model training, you get to a time whereby you want to go into production. And you want to automate the process from end to end. That is when your pipeline picks it from. So, and the pipeline is structured in a way that it understands the first stage where it gets the data from, either from a database or either from a blob storage. It picks the data. The pipeline can be configured also to perform the transformation. After the transformation is performed, it also picks up from the transformed data, do some hyperparameter tuning, go into model development. After model development, it can go into model selection, selecting the best model. After selecting the best model, it can go into now deployment. After the deployment, it makes the endpoint ready. What I mean endpoint, your API that you can consume in your application. The beauty of this is that in the industry we have today, we don't have enough time. I can tell you, we don't have, the time is getting slimmer every day because we have a lot of things to fix. So with a pipeline, all we've said since the morning, you can automate an entire pipeline. And the reason why you need to have an automated pipeline is that the model you use today in the industry, if you build a model, probably you build a churn model today, in the next 1 week, the accuracy of that model will reduce. Unless you have an automated pipeline that keeps retraining the model, selecting the most optimal model to be used for production, you might discover that your model is not performing or is giving you wrong decision. I remember when I was working with as a consultant, and I went to one of the ED who built a model, and the accuracy of the model was maybe 80%, and we were very happy. The ED told me, he said, Edward, before you deploy this model, this same process, can you train this model with the data we got 3 years ago? So like we backroll the model training to a data we got 3 years ago. And by the time we tested it, we discovered that, just imagine, 3 years, that means 3 years from now, we just do a back roll, and we discover that the accuracy of the model drops. So the man told us, he said, see, that means in the next couple of months, the value of your model will be reducing. And that is when I got to the realization of when the essence and the need to build what we call a continuous pipeline. Every day is a new day. Customer behavior changes every day. Customer behavior across different industry, either telco, finance, FMCGs. A lot of things are changing the way customer behaves. So there's a need for us to automate some sort of pipelines to help manage this. And like I mentioned, this is the best part I like. And the reason is that it makes my work very easy and seamless. And with this, I know I don't need to struggle. If I feel there's a change in the distribution or probably in the outcome, I can probably do some extensive deep dive. Like I mentioned, it can help you with automate and orchestrate. So the journey I mentioned was the orchestration journey, how you configured different stages of the pipeline. And also, one of the key components, you have the Python script steps. So I know you can research this more, whereby you can configure the pipeline in your Python scripts. Any one of us that is used to Airflow, the same way you configure your flow in Airflow, that's the same way you have the Python script to configure your flow such that you have different stages, like I mentioned, data collection from data sources, data feature extraction, and model training and hyperparameter, and a lot of steps that is required for the model development. And also we have data store and data set. Those are the key components. And with this, you can also decide and tell the model, tell the pipeline, the kind of compute that is needed. So you have a lot of flexibility when you are setting up your pipeline. And I can tell you, and I'm going to advise you, the moment you get to the industry, please, try and make use of an optimal pipeline. It's going to make you more efficient, and it's going to give you more room for self-development. Another interesting thing, like I mentioned, you're going to have what we call the pipeline endpoints. So you have the API ready for use. So you can just call the API. Maybe there's an application, maybe we that we're in the industry, maybe there's an application picking inference from your model. So the API is readily available for another application to call it without downtime. And I used to tell my colleague, I said, until you get to a level whereby you can make some real-time inference, but without a well-structured pipeline, you will not be able to have a real-time inference. And we have the benefit, it's reusable, you can have automated training. And I think this is my best part, the automated retraining of the model. I don't need to retrain the model. The system, maybe I just schedule, retrain this model every day with new data. And the pipeline goes there and retrains. The only thing I get is, it tells me, okay, Edward, this is the new accuracy of the model. And I can decide to say, I'm going to give a direction to say, an instruction to go ahead or not. So the automated retraining is one of the key features which cannot be overemphasized. And we talk about the scalability, so it can scale underneath, and the parallel execution we mentioned earlier, and that is available, and version and experiment. So versioning means you have different copies of the models at different time, so you can create different version and experiment tracking. So you have different version. There are some time that your current version is not the best. So there are times the current version is the best. So it's going to keep track of different version of the model, the data used, and the process, and the metrics of the model. Okay? And we have from few use cases, from data ingestion, to model training, like I mentioned, model evaluation, the deployment. I said deploy model for real-time inference. And real-time inferencing means in real time you are making recommendation, probably product recommendation to customers. You have to use things like this. And we have automated retraining also. Okay? And some example of the workflow, we have data preparation. It can help you clean your data. So I know sometimes they tell us that in the data journey, your data preparation and data processing takes nothing less than 80% of time. But when you have a pipeline to do the work for you, you just stay on top of your bed and you're just monitoring the pipeline, and you see that the processing is done, and the training is done, the model evaluation and the likes. It keeps the process keeps on autopilot, like I would say. And I think that is that for now. So, and to just give, thank you. So to give a recap, right? To give a recap, we're saying there are key components in Azure, starting with AutoML, hyperdrive, your pipeline to make life better for you. I can tell you, when you get to the industry and when you want to get your hand dirty, and when you want to do something to impact your world, you need a system that is scalable, because your data will keep getting larger, the process will keep getting tougher, and you need a system to simplify the process for you and make it work for you. Thank you very much.